Chapter 3. The Haunted Factory. In his physiology division at the Imperial Institute of Experimental Medicine, Pavlov, from 1890 to 1903, guided the labors of about 100 co-workers to conduct the investigations of digestion that he synthesized in his Lectures on the Work of the Main Digestive Glands, 1897, for which he received the Nobel Prize in 1904. This research was guided by Pavlov's metaphorical view of the digestive system as a complex chemical factory, or sometimes a laboratory, to which he ascribed the very same qualities that he did to successful human endeavors. Both were pravilny, precise and purposeful. As he put it in a speech of 1894, the digestive canal is in its task a complex chemical factory. The raw material passes through a long series of institutions in which it is subjected to certain mechanical and mainly chemical processing, and then, through innumerable side streets, it is brought into the depot of the body. Aside from this basic series of institutions, along which the raw material moves, there is a series of lateral chemical manufactories which prepare certain reagents for the appropriate processing of the raw material. A series of research questions flowed from this conception. What is the activity of this factory at full operation? How and by what is it brought into motion? In what manner does one part go into operation after another? In what manner does the work change in dependence upon the type of raw material? Does the entire factory always operate with all its parts, or not? One cannot doubt that in the investigation of this subject, we will find the very same subtlety and adaptiveness of work that strike us in other, better studied areas of physiology. In laboratory investigations, the factory metaphor expressed and guided the search for pravilny results, for precise, repeated, or stereotypical, and purposeful patterns in the glandular responses of dogs to varying quantities of different foods. Pavlov's lab was also a factory of sorts, a site of tightly coordinated activity that he ingeniously organized and managed in order to enjoy the advantages of large-scale production while also making him a constant participant in work at the bench. Combining free, informal discussion and authoritarian decision-making, his distinctive managerial style harnessed the skilled hands, as he once put it, of a largely untrained workforce to his own scientific vision, multiplying his sensory reach and productivity while ensuring his control over the critical interpretive moments that arose during experiments. When it opened in 1891, Pavlov's lab occupied 5 rooms in the single wooden building that housed all the scientific divisions. But by 1893 to 94, this site could not accommodate the many aspiring co-workers, so he added a new 2-story building. This new labor force was created by a state policy to encourage scientific medicine by supporting and providing privileges to physicians who spent up to 2 years in scientific studies and successfully completed a doctoral thesis. These young physicians were largely unlettered in the sciences, so the prospect of defining, researching, writing, and defending a thesis in 2 years was daunting. Pavlov's lab system was designed to meet this challenge while making the best use of these untrained co-workers. Taken under wing by an assistant, they were trained in lab techniques, indoctrinated into interpretive models, provided with a thesis topic and a suitable dog for their experiments, constantly informed of ongoing investigations, and encouraged to share their thoughts in an atmosphere of free discussion. If the chief found their experiments especially interesting, he joined them at the bench, and when the results proved baffling, the technical or interpretive issues were resolved by the assistant or Pavlov. Reports, articles, and dissertations were composed according to a standardized form and edited, and often in large part written, by Pavlov himself. Pavlov's presence permeated the lab. Unless he was lecturing at the Military Medical Academy, the former Medical Surgical Academy, where he became professor of physiology in 1895, He arrived in the morning, checked the coat rack to ensure that all co-workers were present, and entered the lab to great effect. As longtime co-worker Alexander Samolov described, when in the mornings he entered, or more correctly, ran into the laboratory, there streamed in with him force and energy. The laboratory was literally enlivened, and this heightened businesslike tone and work tempo was maintained until his departure. But even then, at the door, he would sometimes rapidly deliver instructions regarding what remained to do immediately and how to begin the following day. He brought to the laboratory his entire personality, both his ideas and his moods. He discussed with all his coworkers everything that came into his mind. He loved arguments, he loved arguers, and would egg them on. Those arguers, however, rarely prevailed. For one thing, their comments frequently elicited an intimidating outburst of sheer fury, often followed by a sheepish apology in front of the entire lab group. For another, although Pavlov appreciated initiative, he could not give it a wide range, one associate recalled, since this would interfere with the development of his scientific idea, which proceeded according to a set plan. There were important exceptions, however, when a bold co-worker stood up to the chief and changed his mind, or when, as in 1901 to 1903, Pavlov was pondering a fundamentally new turn, recognized his need for special expertise, and recruited a specific co-worker for that reason. Wandering into the lab, one would find co-workers engaged in a seemingly diverse variety of subjects, yet these reflected Pavlov's set plan, his standardized approach to the main digestive organs, the gastric glands, the pancreatic gland, and somewhat less and later, the salivary and intestinal glands. Research on each gland followed a general sequence. Demonstrate the exciters and nervous mechanisms controlling it. Develop an appropriate operation or dog technology to study its functioning in the intact, normal animal. Establish quantitatively the regular patterns of glandular activity, and verify the stereotypicity of those patterns through experiments on one or more other dogs. Research on the different glands proceeded in parallel, each providing models for research on the others. Alongside these principal lines of investigation, Pavlov often assigned research topics designed to fortify the physiology division's institutional position, explore possible new research paths, respond to critics of lab doctrine, or examine puzzling results. This highly coordinated, factory-style lab system produced many specific knowledge claims on the specific exciters of the glands, the role of the vagus and sympathetic nerves, the chemical composition of gastric and pancreatic secretions, and so forth, while providing Pavlov a panoramic view of the digestive factory at work, and supplying the data for his central synthetic claim, that the pravilnost, regularity, lawfulness of this factory was expressed in distinctive, characteristic secretory curves, as the glands provided precisely the quality and quantity of secretions for optimal digestion of various foods. At the center of lab research were surgically modified dogs for use during chronic experiments. As opposed to acute experiments, conducted while the animal was bleeding, writhing in pain, and soon to perish, chronic experiments analyzed ostensibly normal animals over months and often years. Surgical operations to prepare them, then, were developed to satisfy three criteria. The animal must recover full health and its digestive system to normal functioning. The product of the digestive gland must be rendered constantly accessible for measurement and analysis, and the gland's reagent must be obtainable in pure form, undiluted by food or other glandular secretions. For Pavlov, as a convinced nervist, the digestive system could function normally only if these surgical operations left intact the basic nervous relations that controlled physiological processes. Within his factory metaphor, the intelligence of the factory manager was provided not by the psyche, which played a very different role, but by the exquisitely sensitive nerve endings that sensed the properties of the ingested food and directed glands to produce secretions of precisely the quantity and quality necessary for its optimal digestion. The simplest procedure was implantation of a fistula, a thin tube that drew a portion of salivary, intestinal, gastric, or pancreatic secretions to the surface of the dog's body for measurement and analysis. Pavlov refined fistulas for each gland to better meet his three criteria. This proved relatively simple with the gastric and salivary fistulas, but the creation of a normal dog with a pancreatic fistula posed great difficulties. Because of the complex physiological connections of this gland, the pancreatic fistula constantly leaked, causing ulceration and bleeding and undermining the animal's health in dramatic and mysterious ways. Pavlov revised the operation several times, but conceded that this fistula left much to be desired. A second standard operation was the esophagotomy, which accomplished the complete anatomical separation of the cavities of the mouth and stomach by dividing the dog's gullet in the neck and causing its divided ends to heal separately into an angle of the skin incision. Combining the esophagotomy with a gastric fistula allowed experimenters to analyze the reaction of the gastric glands to the very act of eating. Since an esophagotomized dog chewed and swallowed, but the food never reached its stomach, this procedure was termed sham feeding. Just before assuming his position at the Imperial Institute of Experimental Medicine, Pavlov had demonstrated that sham feeding an esophagotomized dog excited the gastric glands, allowing him to challenge the dominant mechanistic view that only the food's contact with the esophagus elicited gastric secretion. In the more hygienic facilities of his physiology division, he succeeded in producing a more normal esophagotomized animal whose gastric glands responded also to mere teasing. A more or less lively representation of food, without any physical contact whatsoever, produced a reagent-rich psychic secretion. The digestive factory, Pavlov concluded, operated in two different phases. The first, psychic secretion, elicited by the animal's thoughts about and enjoyment of food, and the second, nervous chemical secretion, governed by a food's specific excitatory effects on the nerves in the stomach. The Pavlov isolated stomach, devised to study that second nervous chemical phase of gastric secretion, became both a symbol of his surgical virtuosity and the source of the lab's cardinal theoretical achievements. This operation was extremely difficult, but the principle behind it was simple. The surgeon created an isolated pocket in part of the dog's stomach, and did so in such a way that, after recovery, the entire stomach continued to work normally, while this small stomach could be studied separately. Food came into direct contact only with the large stomach, but it excited presumably normal gastric secretion in both the large stomach and the isolated sac. Since the isolated sac remained uncontaminated by food and the products of other glands, the experimenter could extract pure glandular secretions through a gastric fistula and analyze the secretory responses to various foods during the normal digestive process. Pavlov's substantial variation on Heidenhein's isolated sac reflected his nervism. Heidenhein's version involved transection of the vagal nerves, but for Pavlov, this rendered it abnormal. Preserving vagal innervation made Pavlov's operation much more difficult. Very few physiologists were able to accomplish it. But, unlike the Heidenhein variant, it produced a psychic secretion and secretory responses that varied independently in volume and fermentative strength. Judging the normalcy of these dog technologies would always prove somewhat subjective, an inescapable interpretive moment in Pavlovian experiments that sought precise, purposive, and regular results from experiments on complex, intact organisms. As Pavlov well understood, uncontrolled variables abounded, and identical experiments yielded varying results from dog to dog and day to day. One well-recognized variable was the animal's response to the operation itself. Pavlov cultivated the image of lab dogs that recovered to lead normal, happy lives. But the reality was quite different. The pancreatic fistula would lead to various illnesses and eventually to premature death. The isolated sac would slip, atrophy, or become infected. Pavlov himself once revealed that dogs with an isolated sac tended to lie on their backs with their legs up, apparently because they experienced unpleasant or painful sensations when in a normal position. Experimenters, then, necessarily interpreted results in light of the relative normalcy of the animal. The most important variable was the capricious ghost that inhabited the digestive factory, the psyche. Pavlov himself had demonstrated with experiments on esophagotomized dogs the psyche's importance in gastric secretion. According to lab doctrine, it also influenced pancreatic secretion, either directly, psychic secretion in that gland itself, or indirectly, as the acid from gastric psychic secretion excited the pancreas. The importance of the psyche was dramatized daily as both motive force and product of Pavlov's lucrative lab-based business. In 1898, he launched his small gastric juice factory, which bottled the gastric juice drawn from esophagotomized dogs and sold it as a remedy for dyspepsia. In a small room on the lab's ground floor, 5 large factory dogs, selected for their voracious appetite and equipped with an esophagotomy and fistula, stood harnessed to a large table, constantly eating minced meat that then fell through the esophagotomy back into their food bowl. The appetite juice that streamed through their fistulas to a receptacle was purified, bottled, and sold as the natural gastric juice of the dog. Appetite is juice, Pavlov liked to say, but his gastric juice factory, this physiological perpetuum mobile, as he proudly put it, captured the duality of the psyche by converting appetite as a psychological force into appetite as a material, physiological product. By 1904, despite an unscrupulous French imitator and the German preference for pig juice, Pavlov's sales of appetite juice had reached 3,000 bottles per year, increasing his lab budget by over 65%. Most important for him, however, was that this natural gastric juice of the dog demonstrated the efficacy of scientific medicine. Physicians had long preached the importance of appetite, and now experimental physiology verified traditional wisdom and improved medical practice by providing appetite juice to patients who, amid the increasing pace and tensions of modern life, paid too little attention to their food, thus depriving themselves of the crucial psychic phase of digestion, and so falling ill with dyspepsia. During chronic experiments that lasted for hours, co-workers constantly encountered this same powerful and idiosyncratic force. As they fed their dog and collected its glandular secretions, the animal's mood, discomfort, and waxing and waning attention, and its response to a movement, a sound, or experimental setting were immediately evident in the volume of secretory flow. So co-workers were enjoined to study the personality and foibles of their dogs to explain the varying results of identical experiments. These were described in the experimental protocols recorded in the lab notebook for each dog, and in co-workers' doctoral theses. It is taken as a rule in the laboratory to study the tastes of the dogs under investigation, noted one co-worker. Some were passionate eaters, others very picky. Certain dogs are distinguished by a very suspicious or fearful character, and only gradually adapt to the laboratory setting and the procedures performed upon them. In doctoral dissertations, which Pavlov edited scrupulously, dogs were described as peaceful, happy and affectionate, greedy, dreamy, impressionable, excitable, stolid, cunning, and cold-blooded. Coworker and chief frequently invoked these expressions of character or personality to explain the absence of factory-like regularity in experimental results. Only through the complete exclusion of psychic influence, Pavlov believed, could the otherwise lawful operation of the digestive machine be revealed. So coworkers began conducting chronic experiments in separate, isolated rooms and were enjoined to carefully avoid everything that could elicit in the dog thoughts about food. Such procedures, however, could not, even in principle, exclude the psyche from experiments. Pavlov and his coworkers were compelled, rather, constantly to correct interpretively for its omnipresent influence. In his publications, Pavlov portrayed the psyche as a complex actor, regular in its general outlines, but capricious in any individual experiment. On the one hand, it was a constant, objectively measurable participant in the digestive process, producing a predictably ferment-rich initial response to meat and bread, rarely milk, which dogs usually consumed without enthusiasm. One could observe the relationship between the greediness with which a dog devoured a meal and the quantity and quality of its secretory response. The psychic moment, he wrote in lectures, has acquired a physiological character. That is, it has become compulsory, repeating itself without fail under defined conditions, like any fully investigated physiological phenomenon. From a purely physiological point of view, one can say that it is a complex reflex. In chronic experiments, the psyche takes the form as scientific flesh and blood, transformed from a subjective sensation into a precise laboratory fact. Yet, in any specific trial, the activity of this first and strongest exciter of secretion depended on the personality, food tastes, and mood of the dog. It was then, also, a dangerous source of error, threatening constantly to introduce the arbitrary rule of chance to experiments, and so to produce completely distorted results. This contradiction between the psyche as lawful in general, but capricious in any specific experiment, is apparent in the history of the characteristic secretory curves that provided the rhetorical centerpiece of lectures. These curves demonstrated quantitatively the distinctive course of secretion, with separate curves for volume and strength elicited from the gastric and pancreatic glands by the ingestion of meat, bread, and milk. For Pavlov, the precision and stereotypical repetition of these different glandular responses to different foods testified to the purposiveness of glandular work. One must recognize that one or another course of secretion does not exist by chance, but is necessary, useful for the most successful processing of food, and the greatest good for the organism. Yet, Pavlov was acutely aware of the psyche's capricious dimension, and of his selective choice of experiments to convert into curves in lectures. So, after presenting the impressively similar curves from two pairs of experiments, he added, "Of course, not all experiments are so similar as those given, but if such a similarity is encountered in 2 experiments out of 5, or about that, this cannot, in all justice, but be considered clear proof of the strict lawfulness of glandular work." The precise meaning of that sentence is clear from the lab careers of the dogs behind these curves, Druzhok and Zhuchka. Pavlov's scientific style featured the intensive analysis of such favored individuals, or, my term, template dogs. Temperament, technology, and timing combined to make Druzhok the template dog for the gastric glands, Zhuchka for the pancreas. These dogs' secretory responses became the standard against which those of other dogs were assessed, and were enshrined in Pavlov's characteristic secretory curves. Druzhok, Little Friend, was the first dog to survive the isolated stomach operation and proved a model experimental animal, demonstrating, as Pavlov once put it, understanding and compliance during tedious and uncomfortable experiments. The dog's first coworker, Pavel Kijin, would first tease or feed him, wait about 5 minutes for the first drops of gastric juice to appear in the special fistula that ran from the isolated sac, and collect secretions at 15-minute intervals. This continued for only about 2 hours in teasing experiments, but when Kijin fed the dog milk, bread, or meat, both experimenter and animal needed to remain still for 5 to 10 hours to avoid spillage and psychic responses that would skew the data. The compliant Druzhok lay peacefully throughout these trials, even sleeping for 5 to 7 hours at a stretch. Kijin's attempts to distinguish between the secretory effect of psychic and nervous chemical processes were complicated by Druzhok's unusual impressionability and broad self-esteem. After a few teasing experiments, Kijin noted the dog understood that he would not be fed and turns his snout away. So, no psychic secretion. As Pavlov explained, the dog is an intelligent animal and is angered by this ruse no less quickly than a person would be. When Kijin sought to avoid a psychic response by feeding Druzhok stealthily through a cannula into the isolated stomach, the dog often responded to the furtive movements with a greater secretion than when the food was ingested normally. Despite these difficulties, Kijin produced in 1894 a much-praised dissertation that enshrined Druzhok's responses in the lab's first characteristic secretory curves. In collaboration with Pavlov, he established that the curves for the strength of secretion were distinctively different for milk, meat, and bread. But those for amount of secretion fell into two different groups, psychic and usual, that were distinguished not by the type of food ingested, but rather by the animal's psychological response. One could not be certain, even during the second phase of digestion, when the nerves of the stomach presumably responded only to the specific exciters in different foods, that the psychic excitation of the animal had been entirely excluded. This condemned Druzhok to further operations. The lab's prize dog was now esophagotomized and its large stomach fitted with a gastric fistula. The animal's next co-worker, Ivan Lobasov, could now acquire a purely psychic secretion by feeding through the mouth, or presumably a purely nervous chemical response by feeding through the new fistula. Pavlov assigned him the task of bringing more consistency to the psyche's digestive role, incorporating it more fully into the lawful digestive factory. Relying on trials during which Druzhok was fed while asleep, Lobasov and Pavlov concluded that by incorporating a standard psychic response to the different foods, they could now reinterpret Kijin's results for both amount and fermentative power as responses to meat, bread, and milk. Druzhok responded most voraciously to bread, followed by meat. Experiments on milk were terminated after 3 trials because, after exposure to the non-fat variety, he refused to eat it. By this time, 1895 to 96, Lobasov noticed that leakage from the isolated sac ate away terribly at the skin of the belly and disturbed the dog terribly, threatening its health. That introduced an important uncontrolled variable into the trials. When Andrei Volkovich inherited Druzhok in 1897, the dog's secretory responses had become too erratic for lab service. Volkovich began studying a second dog with an isolated sac, Sultan, allowing Pavlov to write in lectures, "Lately, another dog with an isolated sac is stereotypically reproducing all the main facts collected on our first such dog." Results with Sultan and Druzhok certainly bore some resemblance to each other, but they differed sufficiently for chief and co-worker to refrain from comparing the two in the usual rhetorically effective form of secretory curves. Druzhok remained the anonymous template dog behind all the curves for gastric secretion in lectures. In 1896, Pavlov assigned a favorite co-worker, Anton Walter, to do for the pancreas what Kijin and Lobasov had done for the gastric glands. Like Druzhok, Walter's dog, Zhuchka, proved an ideal lab animal. "It is in the steadfastness of this dog," Walter wrote, "that one must find the essential reason for the great regularity of the results obtained upon it. Although Walter had not completed his thesis when Pavlov's lectures went to press, his results with Zhuchka already delighted the chief, who used them to display and explicate in lectures the characteristic curves for pancreatic secretion. Walter and Pavlov's interpretation of experimental trials with Zhuchka led them to the same basic conclusion as had Lobosov's with Druzhok. Under identical conditions, the pancreatic gland responded differently and with stereotypical precision and lawfulness to the ingestion of different foods. This resulted from a combination of psychic secretion and the specific excitability of the gastrointestinal tract. Also, like Kijin and Lobosov, Walter's construction of stereotypical secretory curves relied on interpretation of uncontrolled variables. These included the water content of the animal's body, various factors that influenced the gastric secretion that excited the pancreas, and especially the psyche. This psychic exciter, Walter conceded, is, by the very nature of things, difficult to subordinate to the control of the experimenter. The animal's interest in food varied during and between experiments, inevitably influencing both gastric and pancreatic secretion. With Pavlov's help, he accounted interpretively for the differing experimental results, finding within them the contours of a precise and purposive mechanism. Zhuchka became the Druzhok of the pancreatic gland. Only after the publication of lectures did Pavlov assign 2 co-workers to verify Walter's findings on other dogs. The disappointingly variant results were attributed in each case to these dogs' physiological particularities and individual personalities. In a passage doubtless co-authored by the chief, one co-worker explained that although dogs lacking in Zhuchka's fortunate qualities could not express the same pravilnost in the work of the gland, Walter's analysis preserves its correctness even today. This, then, was the experimental reality behind Pavlov's cryptic comment in lectures about his curves on the factory-like operation of the glands. His phrase, 2 out of 5, referred precisely to his choice of 2 of Kijin's 5 experiments on the amount of gastric secretion elicited by a meal of meat. Kijin had attributed the varying results of these experiments to Druzhok's differing psychic responses. Pavlov chose the 2 in which those responses were almost identical. The "about that" referred to his choice of 2 experiments, or, one might argue, of 6 experiments, of Walter's 24. The powerful impression of such an almost physical precision in a complex organic process, Pavlov enthused, is one of the pleasant compensations for sitting many hours in front of the glands at work. We can imagine Pavlov as he writes this passage, searching through his co-workers' data, finding just the right 2 pairs of experiments, and reflecting about what he had done. He was engaging in a certain sleight of hand, choosing experiments that made his case most convincingly. He signaled this to his readers, I think, both because it seemed the honest thing to do and because he was comfortable with his interpretation of experimental data. He was, after all, following Bernard's dictum to present one's most perfect experiment as a type. That is, to choose the experiment that had been most effectively stripped of the numberless factors concealing the determinism of physiological processes. Pavlov was no doubt confident that, were he to show all his results to an open-minded and experienced physiologist and have the opportunity to explain the complexity of chronic experiments, the variations in personality and mood from dog to dog and day to day, and the other influences that were inevitably at play in experiments on intact, complex organisms, such a physiologist would accept his choice of model experiments. And indeed, although his raw data did not compel belief in a precise and purposive digestive factory, they did cluster in a manner that allowed one, if so inclined, to discern the contours of a factory concealed within. Pavlov apparently did just that, when, in 1901, he used 10 dogs over 10 days to present a live version of his lectures to physiologists Robert Tigerstedt and Johann Johansson, representing the Nobel Prize Committee. He did not, apparently, demonstrate the existence of precise, factory-like secretory curves, but he did convince his visitors that, as they reported, gastric secretion has a different course for different substances, and that the psyche played an important role in glandular secretion. "We have thereby received a new intimation," Tigerstedt wrote, "of the close dependence in which mind and body stand in relation to one another." This was the first of 4 years in which Pavlov was nominated for the Nobel Prize, which he finally received in 1904. One weakness of his candidacy was discomfort with his unique factory system of laboratory production, which gave pause to Nobel Committee members guided by an image of the heroic lone investigator. Pavlov himself had written relatively few works, and his lectures was based almost entirely on the research of his co-workers. As he proudly proclaimed, it was the deed of the entire laboratory. Was this book, then, truly his own? Or was it, as one committee member apparently objected, a mere compilation of the experimental dissertations upon which they are based? The argument of Pavlov's strongest proponent, Robert Tigerstedt, ultimately carried the day. Pavlov had awakened these researchers' interest in the subject, designed and conducted the operations on experimental animals, and conceived, organized, and closely supervised laboratory experiments and lines of investigations. His co-workers' research was entirely permeated by his guiding idea. Although he alone would never have been able to generate the colossal material produced by the lab, the techniques and knowledge produced must therefore, to a substantial degree, be seen to constitute one single man's intellectual property. Only as he was completing lectures in 1897 did Pavlov address in detail the relatively minor salivary glands. He and his co-workers discovered that, unlike gastric and pancreatic secretion, the nervous chemical and psychic phases of salivary secretion were essentially identical, differing only in amount. Whether placed in the dog's mouth, in a physiological experiment, or waved provocatively in front of it, in a psychic experiment, everything edible elicits a saliva rich in mucin, and everything rejected, for example acid or sand, yields a watery saliva. Pavlov initially agreed with co-worker Sigismund Wolfson that the psyche here was rendering a judgment, that here psychology almost entirely overshadows physiology. The research and perspectives of 2 co-workers recruited for their special expertise, however, complicated the picture considerably. Anton Snarsky argued that from a modern Wundtian psychological perspective, psychic salivation was a low-level process that represented not a conscious judgment, but rather the automatic reproduction of an established physiological reflex, an act completely devoid of any element of conscious choice. Ivan Tolochinov demonstrated that the psychic secretion to food obeyed the same strict regularities as did the knee and nictating eye reflexes familiar to psychiatrists. In each case, if unreinforced by the underlying stimulus, feeding or an actual hammer blow to the knee, the psychic response grew gradually weaker with repetition and finally vanished, and it was easily renewed by application of the underlying stimulus. Pavlov had been more reluctant than some co-workers to view psychic secretion as simply a reflex, but was impressed by these and other experimental regularities that suggested a deterministic physiological process at work. He was unconvinced, however, by Tolochinov's view that the essential difference between the physiological and psychic reflex was that the latter acted at a distance. For Pavlov, rather, the fundamental distinction was this: the physiological reflex was an unvarying, unconditional response to the essential qualities of the substance, to the qualities related to the physiological role of saliva, while the psychic reflex was a conditional response to an otherwise neutral stimulus that had become associated with those qualities. For example, to a color, shape, or smell, a noise, or the sight of the person who usually fed the animal. Reporting in French to the Northern Conference of Physiologists in 1902, Tolochinov introduced the chief's definition of conditional reflex, réflexe conditionnel. For Pavlov, both the promise and the peril of research on psychic secretion resided in the conditionality, the inconstancy and apparent capriciousness of the relationship between stimulus and response. Did this conditionality reflect an inherent indeterminacy in the psyche, or did it represent the animal's complex but determined adaptation to the subtlest change in its conditions, to changing signals about available food or an approaching predator? As he put the question in his first international talk on the subject in Madrid, 1903, is it possible to bring together all these ostensibly chaotic relationships into some kind of framework, to make the phenomena reproducible, and to discover their rules and their mechanism? He was sufficiently confident in an affirmative answer to include study of questions of experimental psychology in animals in that year's report on lab activities. The ghost in the digestive machine now became the explanatory target for more than 3 decades of intense and exhilarating research.